I have the ignition on, guys, so you might be able to hear the throttle body buzzing a wee bit in the background. Before I close the chapter on the cooling, just there on the casting, this goes into the cylinder head. Cylinder head block. You can see the engine coolant temp sensor there. You see the little green hex, and you can see I've got the connector removed here. And what I thought I'd show you is, as you guys likely know, at least the guys that are familiar with the SX4, there's two fans mounted on the rad. As you may recall, I detailed them the other day. That's the cooling fan on the left hand side. Right hand side is the condenser fan. So you'd expect the cooling fan to be the only one that operates for cooling, handling the cooling loads on the system, and of course the condenser fan if the air conditioning is turned on, right? And in general that's correct, but there's a wee bit more to it. Let me show you guys, right? I've got a couple of little pieces of ribbon here so you can just see the relative speed. There's, for the cooling fan, there's more than one speed of operation. There's two speeds of operation, single speed for the condenser fan. So there's three relays that actually control the speed of the fan depending on the configuration of them. And there's an additional relay for the condenser fan. I've done a video on this in the past, guys, but I don't want to get bogged down in the wiring diagram detail. If you want, go back in the back catalog and you can bore yourself silly with that, right? So as you may or may not have noticed, the connector is off the engine coolant temp sensor there. And what I've got it done is I've got it wired into my decade box here. So it's a negative temperature coefficient sensor, and basically here's the graphing, right? So as the resistance goes up, the temperature gets colder, and at about 2.3 kilo ohms, you'll get a temperature of about 20 degrees indication, or this will drive both the indication and operate the fans, of course, guys, right? Or on the scan tool, you'll see a value of about 20 degrees. Take my word for it, I've already done that, guys, right? That's not what I'm about to demonstrate here. What I'm about to demonstrate is, you can see I've got just a single parameter up here, the engine coolant temperature, and I've got it in graphing mode here just because it's a wee bit more explanatory, you know, a wee bit better for video purposes as well, I guess. So what I've got dialed in at the moment is actually 95 ohms, and 95 ohms correlates to 43 degrees Celsius. So let's just toggle back to this screen here. 95 ohms, pause around here-ish, the intersect around here. That's about right? So that kind of makes some sense. So the graph is correct, as you would expect in the manual, of course. But again, that's not the point. The point is, how can you use this to actually function check the different modes of your fans? Because what we're essentially doing is just dummying the engine temperature, right? The engine coolant temperature. Instead of having a legitimate overheat to see if the fan operates, we can simulate it, of course. So this is just simulating the values that would be output from the engine coolant temp sensor if this temperature was to prevail in the engine coolant system, yeah? So I'm not going to, well, maybe I will be able to show you both at the same time. This is a negative temperature coefficient sensor, guys, right? That is to say, the lower the resistance, the higher the temperature the system is sensing, right? And the higher the lower the temperature, the higher the resistance. So if you took the connector off completely, right, it's going to indicate like -30 or -40, whatever the default value is here. Let's see. Does it show here? No, probably not. But we can do that. But there's another thing that happens if it does actually sense essentially an open circuit, and I'll demonstrate that as well when we actually get to it. Right, so again, back to the decade box here. Up in the temperature, 50 degrees. What temperature would you expect the cooling fans to kick in? What's normal operating temperature? Around 90 degrees, so maybe just slightly above that, I would think. That's 250 ohms, guys. That's 150 ohms. So let's just go back a wee bit here. So 93 degrees. So now I've got 190 ohms at the moment. 93 degrees, and listen to the fan. So about 98 degrees there, the fan kicks in, right? And you can see a little ribbon. That is the cooling fan in the low speed mode of operation. I don't really need the ribbons, guys, because you can hear it on the soundtrack, no doubt. Let me keep going up in temperature here. So again, the cooling fan is a 2-speed mode of operation fan. So at around, it might be different for cut in and cut out, guys, right? So again, let me go up. So it looks like it cuts in about 97. Maybe not. The cut in, cut out is around the same, I guess. Let me keep going up. So that's low speed mode of operation. 100 degrees. It's getting pretty hot now. And then we're in a high temperature mode of operation. So you can hear the fan, the cooling fan, is kicked into its high speed mode of operation. You toggle between the two there. Maybe see it, you can certainly hear it. Okay, so let me continue to go up here just to demonstrate something here, guys. So again, that is the engine coolant fan operating in a high-speed mode of operation because of the temperature that prevails. That's 140 ohms. And now the condenser fan is actually being commanded on. So at 111 degrees, 110 degrees-ish, that's overheat mode, and even the condenser fan actually comes. So the cooling fan is in high-speed mode of operation. The condenser fan is operating as well. It's a single-speed fan. That's maximum cooling that the fans can actually provide because clearly we're overheating the engine at this point in time. It makes sense, right? Let me just shut that off, guys, so you can hear me talk. I don't have to talk over the fans. So what's happening here is the engine coolant temperature, again, negative temperature coefficient thermistor. That sensor is providing the input. It's basically a voltage divider. Guys, you know how I don't want to get into how the sensor actually works, but it's basically a voltage divider, likely on the 5-volt reference circuit. And what it's doing is, by changing its resistance, it is changing the feedback voltage to the engine control module. Now the engine control module will look at those voltages and discern a certain temperature, as you can see from that value that the temp sensor is actually feeding back to the engine control module. Via these 3 relays, it will configure the cooling fan, or this relay here, operate the condenser fan. Nothing to do with air conditioning if the engine senses that the engine coolant temperature is going into an overheat mode, right? So pretty clever. So there's one other interesting thing that can happen is if the circuit becomes open circuit. So I've just got an arbitrary value here to keep the fans shut up at the moment there, guys, 37 degrees, right? So because it is a negative temperature coefficient sensor, as I said, the higher the temperature, the lower the resistance. Okay, so if it goes open circuit, that must mean the higher the resistance, the lower the temperature. So this will likely show a value of like minus 40 degrees, probably the default open circuit value. But something interesting happens with fans. Let me just take these off. These were just gently put in here, guys, because I know somebody will complain that I'm going to spread the contacts. So minus 40 degrees. High speed mode of operation on the cooling fan, and the condenser fan is also running. So the system is clever enough to know. Let me just put this sensor connected back on. Shut these fans up here, guys. Okay, back to reading. That would be about what I had the car running a wee while ago. That seems quite reasonable, 22 degrees. Now keep in mind, guys, this can be used to check the instrumentation of your engine coolant temp indicator as well, of course, right? So yeah, interesting that the car would see that there's a failure. In fact, I'm sure it would have, let's go back here for a minute. Let's go back. Let's just read DTCs, and no doubt, yeah, there you go. Engine coolant temp circuit high input. And it's a history now because right now it's actually operating. So I'm going to clear that. Go back, clear codes, clear fault code, yes. Okay, done. Right, so I hope that makes some sense, guys. As I said just before I close the chapter on the cooling system, two fans, cooling and a condenser, a 2-speed fan for the cooling fan, low and high speed, depending on the prevailing temperature in the system, and in an overheat scenario, even the condenser fan, nothing to do with the air conditioner, even the condenser fan will actually come on, controlled via these 3 relays here, and the condenser fan relay, and of course the engine coolant temp sensor that lives right down there, threaded into the casting. Well, initially I wasn't going to bother explaining the thermistor circuit, guys, but maybe I will for just a moment. It might serve a purpose for and help some people understand what's going on. So inside the ECM itself, there's a 5-volt reference power supply that goes through a reference resistor, right? So that would be resistor 1 of the little divider circuit. Then that comes out, goes in series with the engine coolant temp sensor itself, which is temperature sensitive, right? Again, negative coefficient temp sensor. The higher the temperature, the lower the resistance. The lower the temperature, the higher the resistance, right? And this is where, this is how the temperature is actually sensed at this point between the two. As I said, essentially just a voltage divider. That's why, if you consider the fact that when we took the connector off, of course, this was open circuit here, and then this 5-volt reference has nowhere to drop, of course, because the ground is missing, because there's no current flow. There would be a complete 5-volt sensed here at the temp sense, and that's how the ECM knew that there was an issue with the circuit. That's why we had the fault code that said engine coolant temp sense high. I'm paraphrasing something to that effect, right? So simple voltage divider, negative temperature coefficient thermistor, the engine coolant temp sensor itself, and this is how the ECM actually senses the temperature. Anyway, I thought I'd include this detail just to kind of, as I said, close the issue on the cooling system. That's it, boys. Hopefully somebody got something out yet. Cheers.